Hello, everyone. This is the lecture for section 3.3. We're going to learn about some differentiation rules. So in section 3.1 and 3.2, we learned what the derivative was, what it's comprised of, how to compute one using the limit definition of a derivative, right? And as you guys might have figured out, figuring out a derivative using the definition is very long. It's very tedious. There's a lot of steps that can go wrong, right? From this section on, we are going to learn shortcuts, some rules that make finding derivatives much quicker, okay? We're going to learn primarily a couple basic ones, and those are going to include the sum and difference rule, the product rule, and the quotient rule for finding derivatives, okay? These are pretty much the basics for the much more complicated derivatives that we're going to be able to see and have to deal with later on in the course, okay? So just to start off, let's go ahead and take a look at these four basic differentiation rules here. So the first one is the derivative of a number. If you take the derivative of a number, it doesn't matter what the number is, 5, 12, 8,000, okay? If you need to take the derivative of that, it's always going to be 0, no matter what, okay? The second rule is the one that we're probably going to be using much more often. Let's say you had a function that is some x to the n power, okay? N being any number you want, okay? Then the derivative of it is going to be n times x to the n minus 1. So essentially what people learn for this rule is you grab the n, drop it down up front, and then subtract 1 from the exponent, okay? The third rule that we're going to use is the constant multiple rule. Let's say you had a function that is comprised of a product between just a good old regular number, c, times g of x, a function itself, okay? Then the derivative of this function, okay, is going to be c, that value, times g prime of x, times the derivative of g. So basically, you can separate the value away, take the derivative of the function, whatever it is, and then just multiply the value back in there, okay? And then the very last rule that we're going to be using is the sum and difference one. This one is exactly how you would think it'd work. Let's say you had a function that is the sum or difference of two other functions, okay? Then the derivative of the sum or difference is just the derivative of each one, and then you take the addition or subtraction of each one, okay? So let's go ahead and just start by, I'm going to do an example really quick, okay? And it's going to use a combination of all four of these that are up here, okay? So let's say I had this function right here. It's a product, okay? So at least for now, what we have to do is we have to distribute. So we'd have to do this times that, right? And then this times that, right? And then this times that, and this times that. We'd have to do all three. So this means my f of x, I'm going to have to rewrite it, is going to be equal to x to the 5th minus 2x squared minus x to the 4th plus 2x minus x cubed plus 2, okay? And if we go ahead and clean this up really quick, it's going to be x to the 5th minus x to the 4th minus x to the 3rd minus 2x squared plus 2x plus 2, okay? So now I'm going to go ahead and find f prime of x, okay? So this is going to use these two rules right here. The constant multiple, 3. The sum and difference, the power, 4. We're going to use all 4 here, okay? So the derivative of x to the 5th, I'm going to use that second rule there, that's going to be 5x to the fourth. I just grabbed the 5, dropped it down, okay, and then minus 1 to the exponent. That's going to be 4x third. Okay, same rule. This one's going to be 3x squared, same rule. Okay, this one is going to need the constant multiple rule. Okay, so I'm going to go ahead and multiply. I'm going to basically separate out the 2. Okay, and then I'm going to take the derivative of x squared. I'm going to take the derivative of that separately. So the derivative of x squared is 2x. So it's going to be 2 times 2x. So this makes this 4x. Okay. The derivative of just 2x is going to be 2x to the 0 power, which is anything to the 0 power is 1, if you remember from pre-calc. So it's going to be just 2. And then the derivative of just 2 is going to be 0. Okay. And then the last thing we're going to use now is the sum and difference. Okay. I found the derivative of each one separately, right? According to the sum and difference rule, I can just grab these all, put them back together with whatever sign was in front of them. So the derivative for this thing is going to be 5x to the fourth minus 4x to the third minus 3x squared minus 4x plus 2, and we are done. So if you wanted to find the derivative using the limit definition, it's going to take you forever, right? With these 4 rules, we were able to find them really quick. It's going to give you the same answer if you did it the long way anyway, okay? So what comes up now is quick checks for everybody. So to show the work for these, I'll make sure you expand them appropriately and just show me that you're taking the derivative of each one separately. If you've noticed, I overly explained this. Once the course progresses a little more, you're not going to need this over explanation, okay? So let me go ahead and move on. The next rule we're going to learn is the product rule. This one's the first funky one that people tend to have trouble with, okay? So suppose that you have a function that is a product of 2 functions. Okay, so it's a g of x times an h of x, okay? Then the derivative of f of x is g prime times h plus g times h prime, okay? Another way that people think about this is something like this: a first function and a second function, okay? Then it's the derivative of the first times the second, right? Plus the first times the derivative of the second. Any which way you want to think about it is fine, so long as in this one, you sort of give the derivative to the right function, okay? You're good. So how does this work out with what we've been doing? So this is the same function from example 1, the very first example that I was doing. I'm going to go ahead and use the derivative or the product rule to find the derivative here. So to do the product rule for this one, I'm going to go ahead and do exactly how the product rule denotes. I'm going to try to take the derivative of this. I'm going to call this first one the first. I'm going to call this one the second. So if f is x squared minus x minus 1, right? Then f prime, the derivative of the first function, is 2x minus 1. And if I call the second x cubed minus 2, then s prime, the derivative of the second, is going to be 3x squared. Okay? So now I just get to follow the product rule to sort of complete my my derivative. So f prime of x is going to be the derivative of the first 2x minus 1 times the second, x cubed minus 2, sorry, plus the first, x squared minus x minus 1 times the derivative of the second, 3x squared. And we are done. Okay. So if you distribute this out and completely collapse it and simplify it as much as possible, you should get the same answer as the very first example that we did. Okay. Notice that this one is a little quicker. Okay. In terms of showing the work for this, so long as you show me something that sort of gives me that you have this down, that you're able to break it down into the first and the second and take the derivatives appropriately, that's going to be enough. Okay. Like I said before, a lot of these problems that I'm doing are overly explained. As the semester progresses, you're going to start dropping off this explanation. Okay. The next thing that comes up here is some quick checks. It's exactly the same ones that I made you do, I think, before, but this time I'm going to make you guys do it with the product rule. Okay. The next rule that we've got lined up is the quotient rule. So suppose you had a function that is the division of two other functions. So let's say you have an f of x that's equal to some g of x divided by h of x. Okay, then the derivative of said function will look like this. Okay, this looks really, really confusing. Okay, long ago, somebody figured out sort of like a thing or mnemonic to help people remember how to find this. Let's say you called the top one the high function, and let's say that you call the bottom the low function. So the top one's high, the bottom one's low. Okay, then the way that you would remember, the way that most people remember this formula for the derivative is low d high minus high d low all over low squared. Okay, so this is how people remember how to find the quotient rule. Okay, so you know, there ain't no shame in just, you know, during the test saying low d high minus high d low. Okay, I can remember it. Okay, so now I'm going to go ahead and use that to find this derivative right here. Okay, so the first thing I'm going to do is I'm going to sort of expand the very top a little bit. Okay, so it's going to be x cubed plus x over x squared. Okay, so just how the formula from above for the quotient rule works out, I'm going to go ahead and call this the high, and I'm going to call this the low. So if my high is x cubed plus x, then h prime, my high prime, is going to be 3x squared plus 1. And if my low is x squared, then my low prime is 2x. So now all that's left is I just need to connect the dots from above. So f prime of x is the low, so x squared times d high, so 3x squared plus 1, minus high x cubed plus x times d low, 2x, all over the low squared, x squared squared. Okay, you can simplify this, but for the purposes of calculus, this is good. Okay, we are done after this. Okay, so if you guys notice, the function itself, I could have reduced it a little more before even starting it, right? And you could, very much so. Okay, but not necessary. Okay, What comes up now, I'm making you guys do some quick checks so you can practice the quotient rule. Okay, so now make sure you have a second screen or something, maybe a tablet or your phone. This has got a QR code attached to it, and I do have the Desmos calculator to the right of this. Just in case you don't have a second screen, you can go ahead and click on it there, do a double window thing on your screen. So now I'm going to go ahead and find the equation of a tangent line to f of x, being that very first example, right, at a specific point x equal 1. Okay, so the way that I'm going to do that is I'm going to go ahead and just use my derivative rule again. Okay, I'm going to use the product rule here. So I know f prime of x is going to be I'm going to use the expanded version of the product rule. So it's going to be 2x minus 1 times x cubed minus 2 plus x squared minus x minus 1 times 3x squared. So what I'm going to do now is I'm actually going to expand this so I can show you that it's going to be the same answer from our very first version. Okay, so if I do the foiling here, right, I'm going to get 2x to the 4th minus 4x minus x cubed plus 2. And then we'll multiply this in, plus 3x to the 4th minus 3x cubed minus 3x squared. Okay, and what I get here is I'm going to combine, let me show you guys. I have that many x to the 4ths. So that's 5x to the 4th. There's this and this x cubed. So it's going to be minus 4x cubed. There's that x squared, so minus 3x squared. There's that many minus 4 x's, just x terms, and then a plus 2 at the end. So this is the exact same derivative from our very first example. Okay, so now I'm going to go ahead and find the equation of a tangent line. So that means I'm going to need a y equals mx plus b. And as you guys can remember, right, find m was number 1 and find b was number 2. So I'm going to go ahead and find m. Since I have the derivative gives us the slope of the tangent line at any x value I want, right? So I'm going to go ahead and find f prime of 1. 5, 1 to the 4th minus 4, 1 cubed minus 3, 1 squared minus 4, 1 plus 2. Okay. 5 minus 4 minus 3 minus 4 plus 2. And that gets us minus 4. Okay. So this is going to be our m. We are done with this bit. So m, number 1, we're done here. The next thing we need now is to find b. Okay, that's part 2. So let me write this out. So this was part 1. So for part 2, we need a point so that we can base our b off of. So what we're going to do is find f of 1. And to do that, we're just going to go ahead and plug it into our original f, not the prime, just the f. So it's going to be 1 squared minus 1 times 1 cubed minus 2. 1 squared is 1, minus 1 is 0, minus 1. 1 minus 2, that's going to be a minus 1 as well. So this is going to be 1. So the point that we're going to be playing around with here is 1, 1. Okay, now we're going to go ahead and find b. So we know y is going to be equal to a minus 4x plus some value b, right, through our point 1, 1. So 1 is equal to minus 4, 1 plus b. And if you do this all right, b should be equal to 5. We found b. Okay, so y is equal to minus 4x plus 5. We are done. So at this point, we have our answer, okay? Now what I want to do is I want to go ahead and use our calculator from Desmos to verify our answer, okay? So we know what our function is. We know what value we need the tangent line to. So we're going to go ahead and take both of those things, and I'm going to do a split screen here. I'm going to go ahead and open up the calculator, okay? And I'm going to go ahead and put in my equation. So my equation is that one right there. So x squared minus x minus 1 times x cubed minus 2. Okay, and I need it at x equal 1. So I'm going to make my a that x equal 1. Okay, so I'm going to go ahead and move this to 1, and there we go. We got our m being minus 4 and our b being 5. So that verifies it. Okay, at least double checks our work. Okay, and I believe that is it for this section, because I think it's lecture questions after that. Yay. Okay. If there are any questions on this material, please stop by my drop-in hours every day now from 3 to 5 in the afternoon. And if you can't make that time, go ahead, send me an email. We can set up something outside of those times. Okay. I'll see you guys around.